Hello class, this is first topic of our lecture, that is why we actually need digital innovations in mining industry. The primary answer for this is certainly safety. The digital innovations promise better safety for mining workers. Principles, Principle in a mining operation is safety first and production must. These are some data from a report of 2018. Wherever the numbers have been reducing since the British period, but certainly these numbers are quite large. And our vision is to make these numbers zero for Indian mines. These are examples of two recent cases that in one of the mines, one of the worker who got overrun by a dumper, whereas as early from 2010 itself, DGMS had a circular that the dumpers operating in Indian mines supposed to have a collision avoidance system. That is basically a digital system which would detect objects like men and cars and all, and depending whenever the system would detect there is a chance of collision or running over, it will automatically actuate the brakes of the dumper. However, in larger section in larger parts of Indian mines, we yet have not seen a wide scale implementation of such technology. And this next one is of an underground mine where a discharge dump was stuck for a conveyor belt, and the operator working there went on fixing it manually, and because of some unfortunate reasons, his hand got stuck, and because of that injury, he got a spot death situation. This kind of situations can be avoided by means of implementing strict surveillance. If anybody is doing some unsafe work, and if there is a penalty for it, and there is a strict message from the administration side that such kind of practices must be avoided, then actually we can avoid such kind of unfortunate deaths. And digital innovations can play an important role here. The primary problem with conventional mining is that worker has to go close to face, where he is exposed to several kind of life threats. Current situation is basically the operator goes near to working face. He senses what is the situation. He thinks what needs to be done and acts accordingly. What we envision is in coming future, the operator may stay away from the face, and therefrom itself he may sense what is the situation, think accordingly, and decide what needs to be done. Though working close to a mine face appears a primitive thing, but replacing this activity with digital technology is no small thing. Behind this hand, there is a human brain, which is a much better computer. And another advantage human-based systems have, that humans are interoperable. That means they can communicate with each other via language and plan accordingly and work as a team. To replace this whole system with digital innovations, our new proposed system also have to have these qualities. And another advantage with human system is that scalability is quite simple. You just create an organizational structure. So you can scale up your mining activity just by recruiting more men. This kind of challenge in case of IoT domain is known as interoperability challenge or scalability challenges. So in due course you will also learn that this is not as simple as it appears, and human can do few things quite efficiently that machines cannot do. still, even though there are challenges for implementing digital things for replacing human workers near the face, the primary reason we still go for it is ethics, that human lives have value and we cannot let our fellow humans work close to the faces. And next, another advantage of having digital things is that uh, compared to humans working near face, machines working near face gives more predictable results. That way, it can also enhance our productivity. And there is also legal pressure on the mining agency to have IoT aided things, or better say digital innovations, for improving safety of mining operations. The regular monitoring is already mandated by law, and in the recent past, we have seen that government agencies have been enforcing digital technologies for this sake. There was a DGMS circular as early as 2009 that mandated having telemetering systems for gassy coal mines, for underground gassy coal mines. And in 2006, and in 2006, the government of USA had a huge change in their Mines Act, which that new act, which is known as Improvement and New Emergency Response Act, that mandated having a two-way communication and tracking system for every human working underground. And as we discussed last time, that data is ubiquitous. In case of industrial processes, every process generates a ton of data. And if we analyze those data well, we can actually predict many things about our processes and systems. So implementation of IoT or digital innovations means we get to collect a lot of data, and with that data we can do several kind of analytics and do a predictive maintenance. You must be aware of the term the downtime. Downtime is a very important concept in case of mining, because when your machines break down, for that period your operations are stopped. One of the primary advantages of IoT in case of mining industry is that we get a lot of data about the processes and operations. That that can help us to do that predictive maintenance, what we call that. Before breakdown, we just from seeing the indications and trends of data, we may somehow be able to predict the breakdowns and failures and all. And whenever, other than that breakdown data, even every kind of data has something to tell. With the analysis of such data, we can make more predictable results from our production and all. So overall, this come under the umbrella of Industry 0.4, 4.0, or the fourth industrial revolution. In our history books, we must be aware of the past industrial revolution. When the age of steam engine came, the time of the time when the British invented the steam engine and took over the other European country by means of economic development. And the second industrial revolution, we call that, when invention of electrical power that revolutionized our production and all. And the third industrial revolution is recent one, where we incorporated IT system in our industry. And now it is being said that we are in verge of our fourth industrial revolution, where we model our industry processes as cyber physical system. And what is a cyber physical system? It is basically a digital twin of your mining or any manufacturing process or any industrial process. It is basically just imagine you making a pot or drawing a picture. Before you do that on paper, there is a image inside your head. Means what's coming on your paper, a twin of that idea is in your head, and that you are producing. So similar thing, but there are limitations of you having a you having an image in your head and putting it in a paper or in production. Instead, we made it little modern, and then we had blueprints. Blueprint is simply a representation of your idea on a paper, which we can do some more operations like calculating volume, calculating area, taking measurements and all. So that way, blueprint is better than having a image on our head. What digital twin is an advancement over the blueprints, where not only the measurements and all, we can also make simulation analysis and the whole product life cycle study over that digital counterpart only. In our meet class, we will discuss more about this concept. So our next agenda is you go through all the materials that is given along with this lecture, and after that we meet and we discuss whatever the questions you have, and we further go into this topic. Thank you.